Hi everyone, this is section 2.1, solving quadratics of integrated 2 KC8. Okay, now, before I started this lesson, I went over a little bit, and it should have been a review of what a perfect square was, right? So any number squared, whatever that gives you, those numbers are perfect squares. So 1 squared, 2 squared, 3 squared, and so forth. So 1, 4, 9, 16, all of those are your perfect squares. Now, I did pass out a factor chart to go with this, and I told you guys not to lose it, okay? And you can use that to find your factors where one of the factors is a perfect square, one of those numbers from our list of perfect squares. So, the square root of 48, if you look at your factor chart, the biggest perfect square that you have is 16. Okay, so this will actually separate into 16 times 3. And we've already done this before, okay, in a previous unit in the first semester, but this is just a review. And the square root of 16 is 4. And the square root of 3 does not have, it's not a perfect square, so we are going to leave it like that. So it's 4 square root of 3. Okay, same thing with the square root of 63. Square root of 63, if you look at the factors on your factor chart, 9 and 7 are factors of them. Okay, so the square root of 9 times the square root of 7 will give me the square root of 63. 9 is a perfect square, which gives you 3. There is no more square root because it is a perfect square, and you bring down the square root of 7. That is my final answer. And last but not least, square root of 125. Factors of those, I know it's not on your factor chart, but it is divisible by 25 and 5. So, square root of 25 is a perfect square, which is 5 square root of 5. Okay, so again, this is a review. We've already covered simplification of radicals. Now, to solve, we want, remember, our ultimate goal is to get the variable alone, to get the variable by itself on one side of the equal sign. Okay, so we're going to find out what the solutions are to x minus 3 squared is equal to 16. Okay, so the first thing you need to do is, because x is inside the parentheses, but outside the parentheses I have this 2, this squared, I want to get rid of the exponent. Okay, that's the first thing I want to do. And how do I do that? In order for you to get rid of an exponent, you are going to use by using a root. So to undo that squared, I'm going to take the square root of both sides of the equal sign. Now this square root and the squared will cancel out because they're inverses of each other. Just like adding and subtracting the same number don't do anything. They cancel each other out. Okay, so this is the same thing. So now I'm left with x minus 3 alone equal to, well, the square root of 16 is 4. However, when you take the square root of something, it will actually give you two solutions. A positive solution and a negative solution of that number. So it's not just equal to 4, it's equal to plus or minus 4. So you can actually split these up into two different equations. You have x minus 3 equal to a positive 4, and x minus 3 is equal to a negative 4. Now you have to solve those individually, right? So I add 3 to both sides here, and I get x is equal to 7. That's one solution. I add 3 to both sides, and I get x is equal to negative 1. That's my other solution. So you do have two different things, so be careful. Okay, so let's go ahead and try another one. I have x plus 5 squared plus or is equal to 27. It's the same process. Okay, so I need to get rid of this squared first by using the square root. But whatever you do to one side, you have to do to the other. So my root and my squared cancel out. I have x plus 5 is equal to plus or minus. Now, the square root of 27 is not a whole number. Okay, if you plug it into your calculator, you're going to get a decimal. So when that happens, you're going to leave it like that. You're going to leave it as the square root of 27. Okay, but you still have two different equations here. You have x plus 5 equal to a positive square root of 27, and an x plus 5 equal to a negative square root of 27. So what I'm going to do is I'm going to subtract 5 to both sides for both of those equations. And I want you to think of a root kind of like a variable. Okay, so when you are subtracting 5 to both sides, the square root of 27 minus 5 is not the square root of 22. You cannot combine those. So in the first equation, you get x is equal to negative 5 plus the square root of 27. You're just rewriting it just like terms that are not alike. And x is equal to negative 5 minus the square root of 27. This is my final answer. Okay, so a lot of the time your answers are going to look like this. It doesn't mean that you're doing it wrong, okay? That's just how it is sometimes. When you're solving quadratics, a lot of them are going to be roots. All right, last problem. Let's go ahead and try number 3. So pause the video and try it on your own. Okay, the first step is to get rid of this 5 though, because you cannot square root when this term is not by itself. So let's get rid of 5 first. So add 5 to both sides. I get x plus 9 squared is equal to 88. Now you can do the square root to both sides. Cancels out the root and the 2. So I get x plus 9 equal to plus or minus the square root of 88, since 88 is not a perfect square. Subtract, or not yet, I'm sorry, split this up into 2 equations. So you get x plus 9 is equal to a positive square root of 88. And the second one is x plus 9 is equal to negative square root of 88. Subtract both sides by 9. You get x is equal to negative 9 plus the square root of 88. And do the same thing to the other equation. X is equal to negative 9 minus the square root of 88. And that is my final answer.